Okay, before we get into the material for Chapter 2 proper, I wanted to review a few concepts from Chapter 1 just to make sure we're all on the same page. And those concepts from Chapter 1 that I wanted to take a close look at right now briefly are the systems analyst. What is a systems analyst? And when we say the system development lifecycle, or SDLC, what are we talking about exactly? Pretty much everything in Chapter 2 builds on the latter point about what is the systems development lifecycle. So let's make sure we nail that down first so we're all talking about the same thing. The systems analyst is a major player in the development of any sort of organizational information system. And just by the way, it's really a good way to get a foothold into a very interesting career in information systems development if you choose to do that. You could call the systems analyst a big man on campus or a big man in the organization with respect to building, with respect to participating in developing organizational information systems using the SDLC. And that slide says this. The slide says key role in information systems development projects, and that's very true. The systems analyst has a variety of roles and skills. In my experience, the very most important skill that a systems analyst should possess is that of problem solving. It's good if a systems analyst has a technical background, that is, came up through the ranks perhaps as a programmer or programmer analyst, but that's not always critical. It's good. The system analyst needs to be able to understand the requirements, the business requirements, that is, what the information system is supposed to do, and should be able to convey that to the more technical people who perhaps actually write the code and design and develop the database systems. Now, the book says that there are 6 skill sets of the systems analyst, or categories: technical, business, analytical, interpersonal, management, and ethical. And that's true, but in my opinion, problem solving and conveying requirements to more technical people who can implement them is probably the most critical skill set of the systems analyst. They have to be able to communicate, that's true, and they have to be good at working with people. They have to have good interpersonal skill sets. Okay, let's spend just a couple of minutes talking about the systems development lifecycle, sometimes just called the SDLC. In our textbook, the Dennis Wixom Roth textbook, they propose and build on a definition of the SDLC that has 4 phases: planning, analysis, design, and implementation. Now, other teachers and people who work in this field may have additional phases, may have security as a 5th phase. They may have 6 or 7 phases, but these are the 4 core phases that most experts in this field agree on. Let's just say a couple of things about terminology. We call planning, analysis, design, and implementation phases. Each phase can be broken down into a series of steps, and the steps, each step relies on techniques that produce specific deliverables. And in many implementations of the SDLC, you need to proceed from planning to analysis to design to implementation, because the deliverables of each phase are necessary to begin the following phase. The planning phase is the first. It's the fundamental process of understanding why an information system should be built and determining how the project team will go about building it. During project initiation, the system's business value to the organization is identified. How will this system contribute to the organization's future success? There is a feasibility analysis that examines key aspects of the proposed project. Technical feasibility, that is, can we build it? The economic feasibility, will it provide business value? And the organizational feasibility, if we actually build it, will people actually use it? The system request is the key deliverable from the planning phase, and once the project is approved, it enters project management, during which the project manager creates a work plan, also a key deliverable, staffs the project, and puts techniques in place to help control and direct the project through the entire SDLC. Whenever you hear analysis, the second phase, you should think requirements. Analysis and requirements, determining the requirements, really are almost identical, synonymous. The analysis phase answers the questions who, what, where, and when. That is, who will use the system, what will the system do, where will it do it, and when will it be used. The project team might investigate current systems and identify improvement opportunities, or they may develop a concept for an entirely new system. This phase, the analysis phase, has at least 3 steps. And developing an analysis strategy to guide the project's team efforts, which may involve studying the current system or looking at ways to design a new system. Another step is requirements gathering, using such techniques as interviews, group workshops, questionnaires, where they analyze this information in conjunction with input from the project sponsor. The system concept is explained through a set of requirements statements and a set of business analysis models that describe how the business will operate if the new system is developed. Notice how that term requirements pops up again and again and again in discussing the analysis phase. The key deliverable in analysis, I should have mentioned, is the system proposal. The analyses, the concept of the system, the requirements, and the models are combined into a document called the system proposal. This deliverable describes the requirements the new system should satisfy. So here we are in design. The design phase answers the question how. How will the system operate in terms of hardware, software, and network infrastructure that will be in place? What will the user interface look like? What sort of forms and reports will be used? What are the specific programs or applications, databases, and files that we will need to put in place? During design, there are at least 4 steps according to these authors. The design strategy, first of all, must be determined, which clarifies whether the system will be developed in-house by the company's own programmers, whether the system might be outsourced and built by another company, or whether the system will simply be bought off the shelf. Those are 3 basic choices: build it in-house, outsource it to another company, buy something off shelf, which is the design strategy. The second step is the development of a basic architecture design for the system that describes hardware, software, network infrastructure that will be used. The interface design specifies how the user will move through the system. Interface design is key. It often determines whether a system will succeed or fail, and that's really what the user will see when they interact with the system. The third step of design is database and file specifications, developing database and file specifications, and these define what data will be stored and how it will be stored. And the fourth step in the design phase of the system development lifecycle is the analyst team develops the program design, which defines the programs or applications that need to be written and describes exactly what each program will do. Now, the key deliverable for the design phase, the third phase of the system development lifecycle, is a system specification that is used by the programming team for implementation. Finally, the final phase in the SDLC is the implementation phase, which is where the system is actually built or purchased, is where the system is built or purchased. And usually this phase gets the most attention. There are at least 3 steps, according to these authors, in the implementation phase: system construction, system installation, and the analyst team establishing a support plan. System construction is, of course, the system is built and tested to ensure it works as designed. System installation is the process by which the old system is turned off and a new one is turned on. Sometimes this is called conversion. There are several different approaches by which you can convert from an old system to a new system. And conversion and this step of installation always involves training. You have to factor in an approach to train the users to use the new system. Finally, the third step of implementation is when the analyst team establishes a support plan for the system. This may include such things as post-implementation reviews, as well as a systematic way for identifying major and minor changes needed for the system. So we are going to go simply with these 4 phases: planning, analysis, design, implementation in this course. However, note that other authors will include some sort of security phase, security analysis, network security, perhaps as a 5th phase. Also maintenance. Maintenance is a huge consideration, and sometimes the ongoing maintenance of a system is a 5th or a 6th phase. Now, why do they call it a system development life cycle? If you think about that term implies that all systems have an end, have a death, if you will. And that's exactly true. The life cycle of a system could be 5 years, could be 10 years, could be 20 years, but at some point it's going to become so obsolete and so difficult to maintain, and the requirements are going to change such that the whole thing will be scrapped or radically modified into a new system. Okay, now let's go on to Chapter 2 and start reviewing that material.